I almost needed a new phone, right? All right. Damn you.
5B right now?
Hmm?
Are you doing 5B?
Yeah, I'm going to do one like it. Stay there. So if I said, find the equation of the line going through negative 1, well, let's just do one exactly like that. 0, negative 7, perpendicular to what two things do you need for the equation of a line? Yeah, slope and some point, and if it's the y-intercept, that's even better. And of course here I did give us the y-intercept, right? So in general I need the slope and some point. Well, the point I gave us is the y-intercept. So that's awesome, it kicks ass. I could use y minus y1 equal, because it'll work for anything. But there's a shortcut. I could use mx plus b. And I know b would be what? B.
The y-intercept.
True, which is what?
-7.
Negative 7. So b is negative 7. The only thing I don't know for my equation then is m. mx plus b. So how do I get m? What do I know about my slope? What do I know about my line that'll lead me to my slope? What's the only thing I know about my line other than it goes through 0, negative 7? It's perpendicular to that dude. Doesn't perpendicular relate what? Perpendicular has to do with the what's of lines. You know, parallel would be the same. But perpendicular would just be negative reciprocal, right? So if only I knew that dude's slope, I wouldn't know mine, because I could just negative reciprocate. So that's the thought process you have to go through yourself. And that's the hard step, is instead of just listening to Jeff say it, I got to freaking say it to myself. And that's exactly the way you do it. You say, I need the slope, he gave me a point, cool. What did he tell me that would lead me to my slope? It's perpendicular. Okay, I know what perpendicular means. If I only knew this guy's slope, and what's the quickest way to figure out that guy's slope?
So don't you like flip it?
I got to first get the slope though, right?
Oh.
Solve for y, because then everything falls into place.
So when you put it in y, it makes sense.
I love it. So subtract 2x. I get 5y equals negative 2x plus 11. Right, enforcing the negative 2x in the right place. And the last step is, some people stopped here and they said the slope is negative 2. Can't be. It's not in the right form. I can't just see it until I get the y totally by itself. So divide by 5. Y equals negative 2 x. Now that's ugly, but do I care?
No.
Because the only thing I need from him is his slope. So I don't care about the 11 fifths. Sometimes I make it on purpose. I say 107.8. I'm not going to do that to you guys, but sometimes I'll do that to people because we don't care. Who cares what that is?
Some people stop.
Ah. Well, I didn't do that to anybody on this one. I made it. I don't even think I made that one that bad. What's our slope then?
Negative.
Careful. That's negative. So our slope is going to be positive 5 over 2. We just change the sign and flip it.
So it's perpendicular.
Exactly. Right? If I could just fill in these two blanks, what's the slope? What's the point? I can then use y minus y1 equals mx minus if I needed to, or mx plus b, which I'm allowed to here because this is b. So now I got everything. Y equals mx plus b. So y equals 5 halves x minus 7. You're done. You just have to fill in those two blanks, right? And m and b, they're variables, so they are like blanks. They're things I don't know yet. So if I can figure out what m is, and I can figure out what b or x1, y1, if I have the other equation, then I fill in the blanks. And I clean it up a little bit, right? This one's nice. It's already cleaned up. I'm done. Okay. So that's how 5b really should go. Pretty much just like that. Any other questions from there? No? Okay. All right. So again, I know that some of you guys didn't get your best grade ever on this test, but I was encouraged by the fact that 29 of you got a passing grade on a pretty decently difficult test. And so I allow you to make corrections, so work on those corrections. I put on there also, I forgot to tell you on that grade sheet, you guys see where it says what you'll need to pass? So right now, we've gotten through about 40% of the grade. We've done 2 tests, so there's 2 more tests. We've done a couple quizzes, there's at least a couple more quizzes. There's a final exam, right? So what do you have to average on everything left to pass the class? That's what that part says, right? So if you have all the homework, isn't that a lower number than if you have none of the homework turned in? That makes sense. You should have to average more if you haven't turned in any damn homework, right? You got to cover your ass somehow. Okay.
So I need to average 60% on the rest of the test in order to pass.
On everything left. So, and like somebody else said over here, it can only get better. You can make corrections. If you haven't made corrections to something, obviously we haven't made corrections to test 2 because we just got back. Some new corrections. If there's some corrections you didn't do from before, it's late, but you'll still get something as long as you get enough of them right. Right? So there are ways to improve your situation from what it is now. Yeah.
Wait, on the missing homework, can you still turn it in or is that the missing
No, you can still turn it in. Yeah. I think somebody once put a comment about me somewhere that said, you'll like this teacher because you can turn in homework on the day of the final. If you turn in chapter 1 homework on the day of the final, I'll take it. It's really freaking late. But you'll still get some credit because the final's cumulative. I want to give you motivation to do your homework if you haven't done it already. So if you haven't done section 2-6 homework or whatever, do it, turn it in. You'll get some credit. The later it is, the less credit you'll get, but do it. You'll always get credit for it as long as the class is still running. So I think last time, before the test, whoa. We got up through section 4.3. That's what was due on the day of the test. So now we're going to get into section 4.4, and I think I kind of gave us a little preview of that the last time I lectured. Because they're word problems, but they're a lot easier than the other ones. They're a little less vague. They're a little more definite. So whenever you see that word applications of something, that's the PC way nowadays of saying word problems. So just give us an example. For production of the musical Wicked, so I'm looking at example 2, page 273. Main floor tickets cost $148. And balcony tickets cost $65. Page 273. That's example 2. They're not all going to be as easy as this one, because believe it or not, this one's going to be pretty easy. But they're all going to be related to this one. They're not going to get very difficult. I mean, the earlier ones are harder because they're so vague. You have to kind of put your own stuff together. This one has definite places for things to go. Suppose that the members of a club spent a total of $2,614. So they spent a total of $2,614 for 30 tickets to Wicked. How many of each type did they buy? That's the question. Right? Let me ask you this real quick. This is supposed to be a word problem about systems of equations. The main thing with systems of equations is there's 2 separate relationships, right? So in this situation, what are the 2 main ideas in here? And I'm going to get some wrong answers, and that's okay. The 2 main ideas, what are they?
They want to know how many tickets that they just bought.
Well, how many of each they cause,
Exactly.
right?
It's individual, so you're gonna do it separately. So you're
You can't do them separately because this number includes both types of tickets, right? And I can't break it up unless I knew how many tickets there were, and that's exactly what I don't know. But there are two ideas here. There is a money idea, and there's an amount idea here, right? Now, what are the two things I don't know? Let's tackle like a normal word problem at first, because I've got to still give myself variables.
You don't know the.
Yeah, I don't know the number of main floor. Who's got a good variable I can use for that? Let's try M.
There you go.
You guys see why I choose M? So you can be nice to yourself. X and Y are kind of like they have no meaning. I know I'm talking about xylophones and yardsticks or something, right? X and Y. So use letters that actually relate so it's easier to remember what the hell it is at the end. M equals 7. Okay, that's main floor is 7. There you go. No question about it. So of course what I'm going to use for balcony, no way. Yeah, stay away from that. One of these equations are always going to be very simple. What much do you get when you add M to B? What do you have to get based on what they said? Is this money? Is this money?
Oh, you're gonna get a ticket.
I'm going to get 30, right? So if I take the number of main floor plus the number of balcony, I've got to get 30. Now the money is going to involve how much does each one of these cost? How much does each one of these cost?
148.
148 for every one of these, plus 65 for every one of those. What's that equation going to look like then?
It's going to be 148 M.
Good. 148 times M. And you guys see that? If I would have bought 2 main tickets, 2 main floor, how much money is that by itself? 2 of these, how much money is that by itself? 2 times this, right?
Yeah.
Well, how many of these did I buy? M. Don't say you don't know. Browser students now, you say, yeah, it's M. Yeah, which is a way of saying I don't know, but still. So how much did it cost me for this? 148 times M. And how much did it cost me for the balcony tickets we got?
65.
65 times B. Exactly. One idea, the other idea. And make sure that tickets plus tickets equals tickets. Make sure that the same idea. You can't add tickets to tickets and get money. I wish. Ticket, money. No, I can't do that. I can turn it into money by multiplying by how much each one is worth. That's what this money plus money equals money. That makes sense, right? And now you attack this any way you want to. You could use substitution. It's really nice for substitution, right? It's also really nice for elimination. Right? So you can do it either way you want to. So let me go ahead and let you guys finish this out. You pick a way and you finish this out. You solve this. Use substitution or elimination. I don't care.
Since we have to get in one by itself, do we just put 0? 1 plus 0?
You can't assume anything about either one because you don't know anything about either one. If you put a 0 in for one of these, you're saying that you got 0 of those. And we don't know. So you cannot plug a number in until you solve for it. So the trick here is, who's doing substitution method? Anybody? You're worried that I'm going to make you come up here or something, but I'm sure more than that are doing it. So what'd you solve for? M. Okay, so on the first one I can take, subtract B. I get M is 30 minus B, and then where can I put that? Yeah, replace M with it. Use one piece of information in the other. So now the second one I can write is 148 times M, which is 30 minus B. I really want you guys to understand, this is just like, I tell you x, y minus z, and I say x is 3, y is 2, z is 4, you just plug them in. Well, now I'm saying M is this thing. You do the same damn thing. You plug that in for M. Everything else stays the same. You're not plugging in for anything else. And now how many variables do I have in this thing? Just one. You just have B. I can solve for B. So now you attack this equation. What is 148 times 30?
That's a good question. 44.
Exactly. 4440 minus 148b plus 65b equals 2614. Right? Now this should be the nice, easy part. Just put your b's together, subtract the 4440, right? Good old stuff. Your numbers are kind of ugly here, but oh well. When you put those together, you get
Negative
83. And over there, you get
182.6 negative.
good. So the last step there is,
divided by negative.
yep, divide by negative 83. And what do you get? So the number of balcony tickets is 22. Cool. It's got to go in evenly because you can't have 21.7 balcony tickets. Right? Even if you cut off a little bit, it's still a ticket. 22, you said, right? So how many, so that's the number of balcony. Oops, at some point I'll erase that. 22 tickets. How many main floor tickets did we have then?
8.
We had to have 8. Right? Why did we have to have 8?
That's
30 total.
Yeah, so one thing is you just plug that back in to the equation, right? 30 minus 22 is 8. Or just realize there's 30 total tickets. If there are 22 of these, there's got to be 8 of those.
How did you make minus 83?
Oh, put the b's together, right? Negative 148 plus 65, negative 83. If you do elimination, you would just multiply this by maybe negative 65 to make the b's go away, right? You can do an elimination. Yeah.
Where'd you get the 8 again? How did you do it again?
Oh,
Sorry.
b is 22. Now, how do I solve at the end of a system of equations? Once I get one letter, don't I just plug it in?
Yeah. Okay.
Or just realize it's 30 tickets. If that's 22, there's got to be 8 of the other one. There's got to be.
Okay.
Yeah. To check yourself, you can do 8 times 148 plus 22 times 65 and make sure it comes out to the right amount, right? You can always check yourself. Okay, maybe. All right, let's do another. Oh, let's see. Let's take one right out of the book here. Let's try this one. Okay, well, number 19. This is on page 278. So this one says Joyce Nemeth bought each of her 7 nephews a gift, either a DVD of the movie Blind Side or the latest Beyonce CD. Lucky little kid. The DVD cost that much, the CD cost that much, and she spent a total of that much. So do you already see how it's getting into a form? You see a lot of problems like this. Number of stuff, cost of stuff. That's your 2 main ideas, right? One of them is always going to be stupid easy. One of them is going to be x plus y equals total. So in this case, how many total things did she buy?
We don't know.
Of course you do.
Oh, X.
No. How many total things? 7. Why? She's got 7 freaking nephews, right? So she bought each of her 7 nephews a gift. So be careful; they're not going to be very direct sometimes. So she must have bought 7 things. And how much it cost her? How much total? Oh, where'd she go? $114.30. So what are the 2 things we don't know? Yeah, how many CDs? My variables. Yeah, how many CDs? And the number of DVDs. So what do you think we're going to call CDs? C. Amazing. And then DVDs? No way. You don't have to, right? If you want to use X and Y all the time, please do. If you want to use your favorite letters ever, please do. But it's not a bad idea to make them relate directly to what it is. My favorite letter, yay! So what's one equation I could do? The simplest equation I could do here. What's got to happen? Yeah, C plus D has got to be freaking 7. You got to see how this sets itself up in a way.
Yeah.
One equation has got to be, the number of things has got to come out to be 7. Right? Number of CDs plus number of DVDs must be 7. Now do the money equation. Each CD costs how much?
C. Wait, I don't know.
1688. Good. So how much money did it cost to get those CDs then, total? 1688 C. I love it, right? Each CD costs that, so I multiply those to see the total amount of money that cost, plus the amount of money it cost me for the DVDs. Good. $14.95 equals the total money I had to spend to get the hell out of there. $114.30. Number, money.
Oh.
Right? And there are 2 separate pieces of information here. That's why I have 2 equations for both. And again, this is awesome. A lot of these are going to have a problem like number 1. So you can do elimination very easily or substitution very easily. One thing you might want to do if you wanted to is you can kill all the decimals, but...
By using elimination.
Sure. Let's do elimination this time. So what would I multiply number 1 by? And don't worry about the ugly numbers. You all have calculators. What would I multiply this by so something would cancel? I like it. You could do just negative 1688, or you can do negative 1495, right? I don't care. So if I multiply this by negative 16.88, I'll get negative 16.88C. So see, those would cancel, wouldn't they? So on the test, I saw a few too many people adding stuff and nothing canceled. That should be a time to erase. If you add things together, you want something to go away. That's the whole idea. Elimination. Eliminate something. If nothing goes away, multiply it so they do go away. So they will cancel out. D times that is negative 1688D. 7 times negative 1688. Help me out. What is that? How can I do that? Let me see.
Okay, so someone had a
6, 8, 4, 1, 1, 8.
trying to find it.
What is it? Help me.
I got it. Hold on a minute.
It's
How come
too
you put
late in the day for me.
1688 twice?
What am I doing to make this 1688 here? I've got to multiply this whole thing by 1688 negative.
11860.
Now, some of you guys, I want to make sure that everyone understands this. I just want a 1688 to show up here, don't I? But I'm not allowed to just change one piece of an equation. If I do something on one piece, I've got to do it to every piece, don't I? That keeps the balance. It keeps it to be an equation. So I know I want a negative 1688 just right here, but to make that happen, I've got to change the whole damn thing. That's the only way I can do it legally. So multiply each piece of this by negative 1688. What do you get there?
118.16.
I almost had it. And of course it's negative.
Yep.
Cool. How are we doing there so far?
So we got the last one about the what? The minus of the 1688 from 1430. What?
All I did was, number 1, I multiplied it by negative 1688. Why did I do that? So that these would cancel. You could have multiplied it by 1495 negative.
I got both of those, but to get the last one, you just.
No, I haven't done anything yet. I took the first one and I changed it.
And it's because
Now I'm going to add them.
It's because you're doing elimination. That's why.
Exactly. I'm doing elimination method,
That's what we're missing.
right? Do an elimination method. So this first one, I'm not even going to use it. I'm going to multiply it by this and then use this. Because then these would cancel, wouldn't they?
Right, but where did 118, 16
Well, if I multiply by 1688,
to 7?
whatever you do to one side, you've got to do the other side, right? Cool.
So you multiply that to 7?
Definitely. Nothing that we've learned before can suddenly change, ever. That's one thing about math. A lot of times students are upset because they say everything's changed. No, the minute you think it's changed, come see me because it hasn't. It can't. So if I multiply one side by something, I've got to multiply the other side by something. We know that. That's the truth, period. I don't care what level you're in. So you can't leave that as 7. That's a common mistake, but normally I think it's just because people forget to do it. You've got to multiply both sides by the same thing. So now if I add these together, what happens?
The C's cancel.
The C's
out.
cancel. That's the whole point, right? C's cancel.
Yeah.
You get negative 1.93.
Okay.
Alright, do that one.
Negative 3 point something or other. 86.
30.
It's 2.
Is that right, though?
I
Yeah.
got 2.
And then divide by negative 1.93.
Yep, that's right.
D equals 2, yeah. Thank God, because again, the answer of 1.7 will make no sense. What happened to that 0.7 DVD? Did you drop it? Did it break? It's still a freaking DVD. It's a broken DVD. Yeah.
So for homework on problems like this, like you said it over there, if we know there's 30 tickets and we can solve for one, do you want us to show work for the other one? Or if we just
No.
we solve
What can
for
you do now for CDs?
C, it's 5 because there's 7.
Because there's 7 total.
Okay.
Cool.
Well, what if you get different answers for subtraction?
Say again.
When you get different answers for subtraction, I did the same thing as the same answer, but if I did subtraction, I got a different answer. It'd be
Well, no, you just got them at a different time, right? Did you get the C first?
I did that. I was just asking.
As long as you end up with the right answer, and you got there a legal way, then you're fine, yeah. Yeah. Alright. I can tell you guys are really excited about this.
The word problems. No.
I know. I don't know if you guys remember, though, the word problems from before. If you think about it, these are better.
They are.
They are less vague. There's only so much it could be.
If it's item, it's the item.
Yeah, but you put in English with math though.
This happens. You got peanut butter in my chocolate. No.
Why'd you say?
Those old commercials where they, what was it, Reese's Pieces? Reese's, oh, you guys are too young. Who's old enough to remember those old commercials where they had the one guy run into the other guy? You got peanut butter on my chocolate.
Oh,
You got chocolate in my peanut butter.
Oh, I
So
think
you got
it
math
was-
in my English. You got English in my math. Who cares? It happens. Let me ask you this, just to make sure that we understand how this works before we get into the word problems with these. If I put, this is not a word problem yet, this is a very straightforward problem. If I put $20,000 into a 5.1% interest rate account, how much money interest would I make in a year? So it's, every year they'll do this, right? Do you guys know how this works? Several of you have accounts. Several of you have this situation in reverse. You take this much of a loan out, and trust me, I just finished paying off one part of my student loans. I got another part to do. You do it the same way to figure out how much interest you have to pay. This is kind of like you getting money, which is much better. How do you figure out how much interest you make? Not divided by. Times, right? It's 5.1% of 20,000. Of meaning multiple. So what do you get for that? It's roughly 1,000. Yep. Are you guys cool with that? Be careful now. Don't make it 0.51. That would be a 51% account. Damn straight. I'm going to put as much money as I can in that damn thing. 5% is 0.05. Move that bad boy back twice.
Yeah.
Yeah.
That's how 20.
1,020?
Yep.
Sounds about right. All right, so in a year you'd make that much money if you had that much to put into that kind of an account, right? So what's the equation here? Anybody know what we call the amount of money you put into an account? Principal, I like it. I can't remember if it's an AL or an LE, but who cares? So this is my principal. I think it's an LE. Probably isn't.
I think it's AO.
I think it's AL.
No,
No,
it's
it's,
LE.
Yeah.
I think it's a UL.
that's right. That's right.
Principal. And at 5%, 5.1%, that's my rate, R. And this is my interest, I. I don't know why I made capital there. So the formula for interest is interest equals principal times rate. Times time, but most of these should be yearly, right? Every year. So it really is times time, but this should be 1 year. So that won't really show up, right? Times 1 won't really show up, yeah.
If moving rate, how you got that 0.051, same as taking it times 10.
Times 100,
Times
right? Percent means per 100.
Okay.
So you always move the decimal twice.
Okay.
Anybody have trouble with changing from decimal to percent? It's okay if you do.
I do it every now and then.
Put the letters D for decimal and P for percent in alphabetical order. If you want to go from a decimal to a percent, you move the decimal that way. If you want to go from a percent to a decimal, you move the decimal that way. So where was I? I was at a percentage, right?
Yeah.
So I want to go to decimal, so which way do I move the decimal place?
Back.
That way. There's always twice. You got to know twice. So if I move it back once, twice, there I am. I made that up a while back. I don't know if that will help. Cool. Because a lot of people think that 8% is 0.8. But again, that's 80%. That's 0.80. It's 80%.
I do that.
Yeah. That's easy to do. So let's do a problem like this. Number 22. Page 279. Number 22. The thing we got to look over is what I always find funny about these interest problems in algebra is the people somehow forgot how much money they put in. Like, okay, that's your first problem right there. Is, you know, come on. If I had $20,000, I think I'd remember it, right? So these problems are always going to be about how much money did they put in the first place because they forgot.
Is this 4.42?
This is still 4.4, yeah. This thing is packed with stuff. So Glenmore Wigan.
That's a name.
I know. Whatever happened to Meg and Bob? Invested some money into accounts, one paying 3%. And the other paying 2%. So we have two separate accounts. So we put some at 3%, some at 2%. Don't ask me why you put it all at 3%. He just wasn't thinking out of it. He earned a total of $11 in interest. Wow. If he invested 3 times as much into 3%, as he did in the 2%, how much did he invest at each rate? So again, you start attacking this the same way. What are my 2 things I don't know? The nice thing is we're allowed to use 2 different variables now, right? Call one of them X, one of them Y, or whatever makes sense. For rate problems, I don't have too much of a suggestion of what letters to use, right? Because it's 3%, 2%. What can you use there? So what are the 2 things I don't know?
How much money they put in?
Yeah, how much you put in. So the money into 3% and the money into 2%. Well, that's the problem. We don't know. Even if they told me it was $50,000, I don't know how much you put in each. I can't just say you put in half because I don't know that for sure. It would still be a problem, right? Here they don't even tell me how much principal he had at all.
Puts 3 times as much in 3%.
Exactly.
And if you have the principal, you know how much one we put into
Exactly. So they can't tell you the principal in this kind of problem. Beautiful. I love it. This is the kind of problem I would actually do the old way, but let's try to do it the new way here. What letters do we want to use for each of these situations?
X and Y.
Okay. So X for the 3 and Y for the 2. So there are two equations you can set up for this. One of them is the easy one. Somebody just told me. You put 3 times as much in one as the other, right? So which one does he have more money in?
X. Wait, we don't know.
He put 3 times as much in this account.
Okay, so yeah.
Oh, okay.
So X is, careful now, it's not 3X.
No,
The amount of money in here is 3 times as much as this one, right? The amount in here is 3 times the amount in there. That's the first equation. It just comes directly from what they told me, right? Okay, cool. So he put 3 times as much in the 3% as is in 2%. So whatever he put in 2%, he put 3 times that in 3. Well, how much did he put in 2? Y. So he put 3 times that amount into the 3% account. So the amount in here must be 3 times as big as the amount in here. Okay. If you remember, it sounds sort of like that Democrat-Republican problem I gave you guys a while back. Remember that? 3 times as many Republicans as Democrats, or whichever way you had it. The second equation is going to be harder. It's the one that comes from what we did here. I equals P principal times rate, right? So how much interest did he make from the 3% account? No, he made $11 total. So I know that the second equation is going to have equals 11. How much of that came from his 3% account? Yes, we do.
0.03.
I love it. 0.03x. Right? Because again, how do you figure out interest? The rate times the money. So he put x of it in there. So how much interest did he make? 0.03x. This is the interest from 3% account. Plus, how much interest did he make from this one?
0.02%
And once you see the pattern, it's the same. 0.02y is how much he made from that one. Interest from 2%. So if you take the interest he made from the one account plus the interest he made from the other account, it's got to equal the $11. There's no getting around that. That's how much money he made total. It's a yearly thing. Yeah, they said, oh, where'd it go? Oh yeah, they don't even say, but they're assuming it's 1 year. Yeah. So who's got a suggestion? What's a really smart way to do this problem? I don't care which way you like. Yeah, because it already says x is 3y, right? So now you just plug a 3y in there for x and go to town. So if you plug this in here, you'll get 0.09y, right? Is that cool?
Yep.
0.03 times 3 is 0.09y plus 0.02y equals 11. 0.09 plus 0.02 is 0.11. That's kind of nice. So 0.11y is 11. Careful. 11 divided by 11 is 1. 11 divided by 0.11 is 100. Cool. You're just doing the calculator, or well, here's a cool little trick. I've got to move this over once, twice to make it a whole number, right?
Correct.
Move the one on the top once, twice over to make it a whole number. What's 1100 divided by 11?
Oh.
100.
Yeah.
Exactly. Or just put it in a calculator. So what does that represent?
That equals the 2% account.
Good. The 2% account, he must have put $100 in there.
Correct.
How much did he put in at the? Yeah, x is 3 times y. So he must have put $300 in there.
Oh.
That sounds like more like my level of accounts. Not the 20,000 probably. All right, maybe. I know that this section is one where it's really easy for me to lose your interest, and I understand. I know, God.
Wait, so wait,
Yes.
go back, so we know that y is 100, so,
If y is 100, x is 3 times y.
something to get it X, how you make it 3Y?
Because they tell me that there's 3 times as much in this one as there is in this one. So whatever's in this one, there's 3 times as much in this one. So X must be 3 times Y. If there was 4 here, there would have to be 12. That has to be 3 times as much there, right? And that's actually kind of a nice one because they tell you times. There's no question that it's multiplication.
How did you type the 3y times the 1.03x? But they're not the same variable.
No. You're replacing X with 3Y, right? Be really careful about that because I've seen a few people when they plug numbers into variables, the variable sort of still is there.
Yeah.
It should be gone. You replaced it. So really right here, I kind of skipped a step. 0.03 times X, but what's X?
3y.
3Y. So there is no X in there anymore. I've replaced it with something about Y. Cool. Let's try one more of these. Oh, yeah, Jeff.
Just skip this section.
No, it's too late for that.
Where you at? See that?
It's actually not too bad right now.
No, I know, that's what I'm saying, so.
Let me see who likes this. I normally do the mixture problems like this, but I haven't done the interest problems like this. You guys all right? Let me show you something about number 22. I'm sure some of your teachers have shown you this possibly. I don't know.
A box, yes.
Little box, yeah.
Yes.
Interest comes from principal times rate. It's just a nice way to organize what you know. So what this really means is there 2 accounts.
No.
So I have 2 rows. So one of them is a 3% account, one of them is a 2% account. So how much did I put into each? I don't know. We called it X and Y, right? And then what's the rate?
0.03 and 0.02.
And then so how much interest did I make? Well, principal times rate is interest, so 0.03 times X, 0.02 times Y. And what do these have to add up to be? $11. So total interest, right? So if you like that, you can do that. And I think the book actually shows you how to do it like that. And it's just a nice way to organize. Because then it's a problem of